In this lesson, we're going to look at simplifying rational expressions. Well, let's start with an example. Let's say we have 20v divided by 70v squared minus 100v. Now, if I want to simplify that, there's a couple ways of going about it. The way that we're going to look at it is with factoring. Well, the numerator is just one term. I'm going to leave it as 20v, but the denominator can be factored. I can take out a GCF, greatest common factor. My GCF is 10v. 70v squared divided by 10v gives me 7v, so that's left. And then 100v divided by 10v is just 10, so we're subtracting 10. From here, I can look for some cancellations. 20 and 10. Well, 20 divided by 10 is 2, so we're going to change this to a 2. Then I have my v's. These guys can cancel. Okay. Well, in the numerator, I'm left with just 2. The denominator, I'm left with 7v minus 10. A common thought is, well, maybe I could just simplify the 2 and the 10 here. That looks nice. No. This subtraction sign ties these two terms together. You can either cancel the entire thing or nothing at all. So this problem is done. This next example is going to be just a little bit different. Let's say I have n squared minus 12n plus 32 divided by 4n minus 16. Now the difference in this one is it's not all about GCFs this time. My numerator can be factored using the AM method or reverse FOIL, where I need to multiply to 32 and add the negative 12. And that's going to be negative 8 and negative 4. So my numerator is factored into n minus 8 times n minus 4. My denominator, however, can be factored using GCF. What I'm going to do is I'm going to take out a 4 from both. Both those are divisible by 4. And what I'm left with is n minus 4. And what you'll notice is we have two like things, n minus 4 and n minus 4. Those can be canceled. And what I'm left with now is n minus 8 over 4. And you might be thinking to yourself, ooh, maybe I could take that 8 divided by 4 and get n minus 2. No, you should not do that. Remember, this negative sign here, this minus sign, the subtraction, ties the n and the 8 together. Okay? Do not separate them. It's all or nothing when you're trying to cancel when there's addition or subtraction involved. This last example is a little bit trickier. Say I start out with 9 minus x over x squared minus 6x minus 27. Well, I can factor that denominator into x minus 9 times x plus 3. And now some of you might be thinking, ooh, I could just cancel the 9 minus x and the x minus 9. That's the same thing. I'm sorry, but it's not the same thing. 10 minus 7 and 7 minus 10 are not the same thing. You get 3 and negative 3, so that wouldn't work. However, they look very, very similar. Now let's think. This 9 here is positive, but here it's negative. This x here is positive, but here it's negative. Basically, the signs have been switched. You think to yourself, well, what could I do to switch a sign? And you're right, it does have something to do with a negative 1. What we're going to do is we're going to factor out a negative 1 in the numerator. So if I take out a negative 1, I'm left with, well, negative 9, and then change the sign for the x. I'm left with positive x divided by x minus 9 times x plus 3. Now it still doesn't look quite the same, but we can change that. We're going to have negative 1 times x minus 9, because addition is commutative, right? This addition here, I can move the x and the negative 9 to different spots. It's still the same thing. Divided by x minus 9 times x plus 3. I can cancel these two, and I'm left with negative 1 over x plus 3. Always remember, even if I had nothing up in the numerator, nothing up here, even if there was nothing left up here after I canceled, say there was no negative 1 here, it would then be 1 over x plus 3. You can't just have x plus 3 if you cancel everything out in the numerator. Do not forget that.